Hey guys, today we're going to try a live online assessment. So a mock interview, the easiest level. So let's see what questions I'll get. So the first one, given an array A of non-negative integers, half of them are odd and half of them are even. I need to sort them so that whenever A of I is odd, and whenever A of I is even, I is even. Okay, so I think I might just separate the even and odd integers and then alternate between one and another. So I could do like evens are the array filtered if the value does not have a remainder with true. And then I have the same thing for the odds, except this needs to be true. So there needs to be a remainder with true. So now I have the evens and the odds. And then what I could do is I could have, since half of them are evens and half of them are odds, I can have a result array. And then I could return this array later on. And I could just loop through all of the indices in the evens array, right? Like this. And yeah, and then I just push. So for example, at the index 0, I want an even number. So I would do results dot push evens dot shift, or pop, doesn't really matter. So let's do pop, although that changes the length. So I should do something like while I still have evens, sorry about that, while I still have evens in the evens array, while I still have elements in there, then I pop one, and I also pop one from the odds array. And that should be it. And I call that odd for some reason instead of odds. So let's see if this is working. Yeah, even, odd. So looks like it's okay. Let's see. And it gets accepted. So let's go to the next question. Next, increase keeping Skyline. I have a two-dimensional array grid. Each value is the height of a building, and I can increase the height of any number of buildings by any amount. And height 0 is also a building. And at the end, the skyline, when viewed from all four directions, must be the same as the skyline of the original grid. Okay. What is the maximum total sum that the height of the buildings can be increased? Okay, I see. Right, so I can only increase the height of a building at most up to the maximum of its row and the maximum of its column. So I need to keep the maxes. So max columns, and also I need max rows. So I need those two maximums so that I can then set every building to the maximum in the column and in the row. And then that won't change the skyline. So what I'll do is I'll loop through. I'll just have this as like negative infinity. So new array with grid length, actually grid of 0, because it might not be a square. I don't know if it is a square or not, it doesn't matter. And fill that with minus infinity. And then max rows is that again. So now I have two arrays with all infinities, and then I loop through all of the indices. So start from 0, go up to the grid length, then start from 0 and go up to the number of columns. Yeah, maybe I should use a different index. What do you think? Okay. And now I can update my maximums. So I should do something like max columns of j is the maximum between max columns of j and the element, the current element. And I should do the same for the row, except I use the index I and the max rows, like this. Okay, and then I should have like a result, and that should be starting with 0, and at the end I return the result, and then I loop again through all of the positions in the grid, and I increment the result. So I do result plus equals the difference between the current value and the minimum. What should I do here? It should be like if it is less than the maximum of the column and it is also less than the maximum of the row, then I can have a better result. I can improve my result. So I should say if my current element, so this is my current building, and if the current building is less than the maximum in its column and it is also less than the maximum in its row, like this, then I can update the result. So I could do result plus equal the difference between the minimum, so the minimum of the column and the row, like this, and my current element. So the difference is the minus, and there we go. I think that should work, unless I missed something. And yeah, I did miss something, so what's the problem there? Output 0, curve building max columns of J. Grid of J does not exist, of course, so yeah, this never runs. Like this should now actually work. And again here, once more, I should go with I.length. Yeah, I don't know what I was thinking there. It's just coding and talking at the same time. And now 37, the output should be 35, so we're still missing something here. So what's the problem? Let's see. So the max should be working. So let's see the column. Oh, well, missed another index there, so should be I. Let's see if now it's working. Yeah, talking while coding is hard. And okay, that's 2 problems in 10 minutes. I don't know. And then the third problem. On a 2-dimensional grid, there are 4 types of squares. The starting square is 1, 2 is the ending square, 0 are the empty squares, and -1 are the obstacles. And I need to return the number of 4 directional walks from the starting square to the ending square that walk over every non-obstacle exactly once. What are the limits on the size here? Only 20. Perfect. So first of all, I need to find the starting coordinate and the ending coordinates. So I should do start is start x and start y. Should be find start, and or actually I could do like find where and then I give the value, so I don't have to write 2 functions. Find where the element is 1, find where the element is 2. So this is going to be a separate function that adds access to the scope. So find where value, and then we just loop through every position. And then we loop through every column. And then if the grid at this row and this column is equal to the value, then we return row and column. And yeah, there's always going to be at least 1, so we don't have to worry about never returning. And this should be a destructuring of the array that is given as a return value. Okay, so now we have the coordinates for the start and the end. And now we need to find how many zeros there are. So yeah, let's just count them. So I'll have amount of zeros, amount of walkable, let's call walkable squares. That's going to be count zeros. And count zeros, again, is going to be a function that doesn't take any parameter, loops through all of the grid, and returns the result. So we increment the result by 1 if the grid at row column is equal to 0. So like this. And the result should start at 0, sorry. Unless, well, yeah, we'll have to deal with how we want to, like, do we want to count the 2 and the 1 as walkable square? We'll look at that later on. For now, let's just have it like this. Okay, so now I have the amount of walkable paths or squares. And now I should do like a, I think the limit is low enough. Like the size is only 20. So I could literally try every path and then check every path of length amount of walkable. And yeah, and then just return that. So how do I basically enumerate every path of length 20? And I want to make sure that I only count all of them once. So that could be a breadth first search. Let's see. Yeah, let's just start writing it, and I think it will come by itself. So my result is going to be 0 at the beginning, and at the end I will return it. Now I'll have some kind of a visit of my grid. So let's see. Well, first of all, I'll write the 4 directions. So I'll have my directions like this, and I'll have 0, 1, 1, 0, -1, 0, and 0, -1. So these are the directions in which I can walk, because I can't go diagonally. So I can only go up, down, left, or right. Perfect. And now what I should do is I should probably have a recursive function. Yeah. Okay, so I'll have like a queue. Yeah, let's do it with a breadth first search. So I'll have a queue that stores the length of the path that I'm currently taking and the square where I'm at. I can only walk on every non-obstacle square once. So that could be a problem. How could I store that? Well, I mean, the limit is so low, honestly. I could just have a set for every path or something like that. Or let's see. So let's see how would I do this if I was doing this by hand. So for example, let's have this down here. So remove this. Have a new line. And there we go. So what would I do if I was doing this by hand? I would start here. And then I would probably go here. I don't think is as far as dynamic programming. Yeah, I don't think that's it. Every path needs to go on non-obstacle squares only once. So how could I do that? Yeah, I just start. So I start here, and then I can go either here or here. And then from here, I could have just a set. Yeah, I could just have a set. Right. So I start a depth first search from here, and I have the set of paths that I can walk over. And at every step, I just duplicate it. Although, then I should have had a set instead of this. So that's not good. Because I just counted the zeros, but maybe I should have put them all in a set. so that I can have its size, and that would be the same as the count. And then I could duplicate the set. Yeah, and then I don't even need the length, because I can just... No, I still need to duplicate it whenever I choose where to go. Oh yeah, that's fine. So I need a set where the values are, I mean, the limit is so low that it could be an array, but anyway, the value in the set should be like comma separated row and column. So I'll have my set of zeros, like that, and then anytime I find one, anytime I find a zero, I should add to the zeros row plus a comma plus a column, like that. And now that I have the set of all of the zeros, then I can start a depth first search. So I'll have a depth first search. Let's have a function here. And it starts with the coordinates. So I'll have to call it with start x and start y. And this will add it to my result. And the parameters are x, y, and then the zeros set. And set, let's just have it like set, and we pass in zeros like this. Okay, and now what we do is we check if we are in the bounds. So if we are out of bounds, then we return. So if x is greater or equal than the grid length, and or x is less than 0, or y is greater or equal than the grid length, or y is less than 0, then we just return straight away. Otherwise, if we need to loop through all of our neighbors, and if they are walkable, so they are like zeros, then we go to them, right? And we clone our set. So we should do every possible change of directions. And I've created them here. My neighbor is going to have neighbor x and neighbor y, and those are my x plus the delta x and my y plus the delta y. And then I should check if the set of zeros has this couple of coordinates. So check if it has new x plus a comma plus the new y. And if it does, then I should call my function on a cloned set, but without this. So I should probably do something like set.remove this. And then I call DFS again. DFS on the new x, the new y, and a new set that has all of the elements of the last set, like this. And then I should add back in the 0. Okay, and now all that I need is to check if my neighbor is the ending square, and if so, then also check if the set size is 0, and if so, increment result by 1. So if the neighboring x is equal to the end x, and the neighboring y is equal to the end y, then I should increment result by 1 if the set size is 0. And then I should return, because the path cannot move forward. We cannot pass through the end and not end there. Okay, I think that might be it. I mean, obviously there's going to be something that doesn't work. So yeah, we get 0, which is not the correct answer. The answer should be true. So let's see what's the problem. 0 is a new set, and we are never calling count zeros. So yeah, let's just call it randomly like this. I don't know. Okay, let's see it now if now it works. Set remove is not a function. Is it delete? Doesn't matter. Delete or something. I guess I'm using too much stack space. So what's the problem here? Because the grid is so little that it shouldn't be a problem. So, yeah, this should be okay. Where's the problem? I think we're just going to do some logging. This is not useful now. Let's just do some logging and see what the problem is. So first of all, let's see if the count, if the finding and the counting of the zeros are fine. So let's log the start x, the start y, the end x, the end y, and the zeros set. Let's see if that at least those are correct. So the start x and start y should be 0, 0. Perfect. End x and end y should be true. 0, 1, true. And 0, 1, true. Yes. True, true. Okay, perfect. And then this should be the set of all zeros that are available. So 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, 1, 2, 1, 3, 2, 0, 2, 1. Yeah, those are correct. So this part at least we got it. So now let's see what the problem is here. Called the FS on X and Y. And I should also log the set. Okay, let's see what happens. There's probably like 2000 loggings. Yeah, because it's running for too much. Perfect. So yeah, it's just calling itself on over and over on himself basically. Yeah, so why does it go again? Like it's calling the FS on 0, 3 and then going on 0, 3, 1, 3, 0, 3, 1, 3 again and again and again and never going back. Although I should be removing from the set. Yeah, I'm not understanding what the problem is here. Because I'm removing from the set the neighbor before cloning it. And then I'm adding back in. But it doesn't matter. Yeah, like, no, it does matter because for the next iteration, I do want to have. Yeah, or another thing that I could do is, yeah, but I don't think that's going to make some difference. What I could do is I could have, yeah, it doesn't help. I was thinking of putting this in an outer variable and then filtering it to remove this instead of deleting, but it doesn't help. So let's see. Oh, I'm always doing zeros. And hopefully that was the problem. Let's see. And the output is still only 0 for some reason. So I'm going from 0 to 0, 1, 0, 2, 0, 3. So I'm going here. And then I'm going to 1, 3, 1, 2. And for some reason 1, 2 again. Instead of moving through here, I'm going back for some reason. Let's see. Need to debug this. Start X, start Y, and X and Y are correct. Yes. Okay. This is correct. Yes. So why is it going? Yeah, well, it looks like the set is not being resized correctly. Like here, I'm going from 0, 0 to 0, 1, then to 0, 2, then to 0, 3, then to 1, 3, then to 1, 2, and then like I'm stopping or what? Like it's kind of like if I'm stopping there instead of moving through the neighbors. New X and new Y. For every direct. Oh yeah, maybe it's. Yeah, it's because I'm returning. I shouldn't be returning. Yeah, I should like doing break or something like that. So I should break because I don't want to go there if it's not the end of my path. So like if it is the end of my path, then add one to the result. Otherwise, just break and keep going through the other neighbors. I think that was the problem. And now the output is still 0, but we have some more progress. So we're going from 0, 0 to 0, 1, 0, 0, 0, 2, 0, 3, 1, 3, 1, 2. Then again here, it kind of looks like if we are stuck. Let's look at the set size as a way of knowing whether or not we are moving forward or we are backing. We are like backtracking. So yeah, here we are still moving forward. And then for some reason here we stop. So we never get a 0 size set. So that is a problem. So why are we stopping here? So we went here, then we went here, then here. Then we went here, here, and then we stay here for some reason. Why? Why don't we go to 1, 1? Although we do go there, but with a much larger set size, so that's not good. Why is it not? Maybe I just forgot the directions? No, I think those are good. Then what is the problem here? The set needs to have the new coordinates, and that's correct. Let's see what the problem is. Let's have some more logging. So I'll do, okay, got to the end. Okay, let's log the set size when we get to the end coordinates. And actually, I meant to have a continue here. What the heck am I doing? That should be a continue, not a break. Oh my god, that is embarrassing. And now it works, of course. So yeah, it just was a typo all along. So yeah, I just need to continue to the next iteration instead of breaking. Because like doing break there was the same as return. And now it works, of course. So yeah, that's really dumb by me. But yeah, talking like coding is not too easy. So yeah, that's it for me today. Thank you for watching and bye.